Towers like this one can be seen in their hundreds in the Italian countryside. Almost all small towns have one. They're elevated water towers. Sitting on top of a concrete pillar or stem, there's a reservoir capable of holding hundreds of cubic meters of water. Just like this one, located near Turin's Caselle Airport, with a reservoir weighing 400 tons. Now, how can the tank be lifted up there? Is it first built on the ground and then pulled up with ropes, like in ancient Egyptian times, or is it hauled up on inclined wooden ramps? No, none of these. Just think, here we're only on the first floor. This is the plan of the tower, and we're right here, almost at the bottom, in this area, at the top of the first section of stairs, and we still have a long way to climb to reach the base of the huge reservoir we can see here in the cross-section, at a height of 33.5 meters. This is the bottom of the tank, which can hold 600 cubic meters of water, weighing 400 tons, and this is the top. The stem is now 33.5 meters high and will need to grow to 39 meters before it reaches the right height. Climbing up inside is no easy task, although it can be done. And it's interesting being inside here for a specific reason, because here we can find the first traces, here on the wall. Here they are, this stripe, which you can see very well on the other side. Here it is, separating the lighter concrete from the darker one. Over here there's an even clearer example, also dividing the lighter shaded concrete from the darker one. These are the segments, the 40-centimeter high steps, by means of which the stem and the tank it supports are raised up to a total of about 45 to 50 meters, and the work is done mechanically. Now we're exactly in this point here. We need to reach here, or just beneath it, because the tower hasn't been completed yet. The stem is unfinished. But take a look at one of these windows shaped like portholes, which are necessary for ventilation and for providing light, because here you can see a metal pipe inside the whole length of which there's sand. The sand serves to support the foot of the machine that lifts these concrete segments up one by one to build the structure. They're jacks using hydraulic power, which means that they're operated by fluid, and they need a support on which to stand. The pipe with the sand has precisely this purpose, to support the jacks. These are the hydraulic jacks that literally lift the structure without having to haul it up with ropes. Each jack can lift a weight of about up to 150 tons. There are 12 of them, and it's their job to push up this 400-ton structure, and they can certainly make it. This is the base they're pushing up. As it rises, pushed up by the jacks, it takes this up with it in 40-centimeter steps, one on top of the other, 40 centimeters at a time, up to the 38 meters where the tank is. Now we're right at the top, just below the tank. This is the base of the tank, made of metal, that will be raised, lifted up, and we're right beneath it. These are the last 12 meters of the whole structure, and here we can see very clearly the steps that have been made for the tank. This is the plumb line to make sure the structure is perfectly vertical. And now we can see what's happening right before our eyes. We can see this metal part rapidly rising. If we measure with this ruler here, we can see how this shiny metal part is rising. This part here, it's already risen by at least half a centimeter or more. We can measure the distance from the concrete. We're at 3 centimeters right now, while the hydraulic pressure of the oil inside the jacks is increasing, and they're pushing up on their foot on the sand contained in each of these cylinders. so that they can push up the tank above us. If we stand still now, we can actually see the movement. Here it is. If we stand still, we can see it going up right now. It's opening and we can see the shiny metal part as it grows. That's the jack's piston. Let's take another measurement below to see how far it's risen. With the ruler, it reads almost 10 centimeters. In a very short amount of time, we've almost reached the 20 centimeter mark, which will then become 40, then another 40, until the tank reaches the desired height. What's happening here instead is the pull of the jack, which drags the part of the pipe along with it. The sand is dropping down right now, inside the metal sheathing below. While the jack is pulled up, then it's put under pressure again, and we've gained all this space here. From here, from the concrete mark, up to the base that's going to stop now. There we go. This is how these water tanks are lifted up all over the country. They're built just like plants grow from the bottom up. They're not made on the ground and then lifted up. It would be an impossible feat, considering the weights and volumes we're dealing with here. This system of jacks can raise tanks weighing up to 2,000 or even 3,000 tons. The water tank near Caselle Airport is almost finished now. The concrete stem, when finished, will be 38 meters high, and the whole structure, including the tank, will reach a height of about 50 meters. These are small-scale works, but they're very useful because they enable us to have running water in our homes at the right pressure all year round, because the water drops from high up and can keep its pressure at all times.